Today we want to take a look at two ideas, force and work. So let's start off with a force problem. We want to take a look at stopping something on a slant. For example, a car parked in a driveway not rolling out into the middle of the street. So if we want to stop something on a slant, we want to go ahead and take a look at our vector W, going straight down. That is the weight of the object. So we've got our vector W, which is the weight of our object. That's made up of two vectors. Our vector U is parallel to our slant or our hill. So I've got my vector U here. And we've got our vector V, which is always perpendicular to the slant of the hill or the driveway, whatever it may be, which means that U and V are always going to make a 90-degree angle. So this is always going to be a right angle right here. Now in that right angle, we have two angles, the angle in between vector U and W and the angle in between vector W and V. So if I take a look at trying to stop something from sliding downhill, that means that I'm traveling along U. Then I want to use my angle theta in between U and W. So if I want to find the magnitude of force, how much force do I need to stop an object from going downhill, then what we're going to do is we're going to find the component of W along V, which is the magnitude of W times the cosine of theta, where theta is the angle in between U and V. If I want to find how much force my driveway is experiencing, now think of this pushing down. So if I'm pushing down, I'm going towards my V, so I'm being pushed down here. Then my angle theta is then in between W and V. So let's go ahead and take a look at an example of this and how we can find our magnitude of force needed either to stop an item from going downhill or how much weight or how much force my driveway or slant is experiencing. So if I take a look at my question number 1 here, it says a car weighs 2,500 pounds and it's parked on a driveway inclined 10 degrees. Now, I don't know why, but for some reason, when we printed this out, it's got this weird little Y symbol. That's our degree symbol. So anytime you see that in these notes for some reason, it's your degree symbol. We want to find the magnitude of force required to prevent the car from rolling down the driveway. So let's create our 3 vectors here. My vector W is always straight down. Then I've got my vector U, which is the driveway. So here's my car parked on the driveway. And then here's my vector V, and I know that vector U and vector V are always perpendicular. Well, I also know that my driveway and the ground are going to make an angle. So let's go ahead and draw the ground in here because they tell me that the angle that my driveway makes with the ground is 10 degrees. So this little angle in here is 10 degrees. I know that a vertical and a horizontal line are 90 degrees. So if that's 10 and I've got a 90-degree angle there, then the angle theta in between U and W is going to be 80 degrees for my car being parked on the driveway. So let's go ahead and take the magnitude of W times the cosine of theta. My magnitude is any measurable amount of my vector. Weight is my measurable amount of my vector W. So we're going to take 2,500 times the cosine of 80 degrees. And 2,500 times the cosine of 80 degrees, plug that in my calculator, and I get about 434 pounds of force needed. I'm just going to use the symbol pounds of force. Now, in part B, we want to find the magnitude of force experienced by the driveway due to the weight of the car, so being pushed down. So if I go ahead and I have my same picture here, I've got my vector W, here's my vector V, here's my driveway with my car, and I know that from my first picture that the driveway is inclined 10 degrees, this top angle here is 80, which means that the angle in between W and V has to be 10 because that top angle there is a right angle. So this time when I take the magnitude of, magnitude of my weight times the cosine of my angle, we're going to take 2500 times the cosine of 10 degrees, and my driveway is feeling 2,462 pounds of force. Maybe instead we have a girl pushing a wagon. So same idea, let's look at question number 2. It says that a girl is pushing a 50-pound wagon up a hill that's inclined 20 degrees to the horizontal. She stops to rest. Find the magnitude of force required from her to prevent the wagon from rolling down the hill. So let's go ahead and here's my hill. Here's my vector W straight down. There's my vector V. Here's the ground. So I've got my girl here, put her in pink. Give her some hair, give her some arms and legs. Here's her wagon, and she stopped here on the hill. It says that the hill is inclined 20 degrees, and I know that my vector U and my vector V make a 90-degree angle always. I also know that a vertical and a horizontal line make a 90-degree. So if that's the case, and I have a 20-degree angle and a 90-degree angle in my right triangle there, I know that that top angle theta is going to be 70 degrees. So now, if I want to figure out how much force is needed to stop her from going down the hill, that would be the magnitude of W times the cosine of theta. So the weight of the wagon is 50 pounds times the cosine of 70 degrees. And we need 17.1 pounds of force. So this is our first type of problem. Now let's take a look at work. Work is the dot product of a force vector with a distance vector. So it says that work, I'm going to multiply my force vector with my dot. I'm going to multiply my force vector with my distance vector. I'm going to find their dot product. So for question 3 here, it says a force is given by the vector F, 7, 6, and moves an object from the point 2, 1 to the point 5, 6. Find the work done. Well, if I look at my work equation, work is the dot product of my force vector with my distance vector. I have my force vector, I don't have my distance vector, but I know how to find my distance vector if I have my starting point and my ending point. So I want to find my vector D. I'm going to take the difference of my x's, 5 minus 2 is 3, and I'm going to take the difference of my y's, 6 minus 1 is 5. So for my distance vector, I travel forward 3 and up 5. So I now can find my work. I'm going to take the dot product of the vector 7, 6 with the vector 3, 5. Remember that to find the dot product, you're going to multiply your x components together, 7 times 3, plus I'm going to multiply my y components together, 6 times 5, and that's going to give me 21 plus 30 is 51 foot-pounds. Now let's take a look at number 4, our last problem. It says a man pulls a wagon horizontally by exerting a force of 30 pounds on the handle. If the handle makes an angle of 70 degrees with the horizontal, so let's put that 70-degree angle there with the horizontal, find the work done in moving the wagon 200 feet. So first we have to find our force vector, then we have to find our our distance vector. So to find my force vector, I don't have my left to right move and my up and down move, my x-coordinate, my y-coordinate. But I do have my angle and I have my magnitude. So I know that to find a vector, if I don't have my left to right and my up and down move, I can also use the magnitude, so 30 degrees, times the cosine of my angle, 70, and my magnitude, 30 degrees, times the sine of my angle, 70. I also need to find my distance vector. How far did I travel? Well, it says that I'm going to move 200 feet. So I'm going to go forward 200 feet, up 0. Now that I have a force vector and a distance vector, let's find our work. Work is the dot product of my force vector with my distance vector. So to find the dot product, I'm going to multiply my x components together. So I'm going to take 30 times the cosine of 70 degrees, multiply that by 200, and we get 2052. And then I'm going to multiply my y components together. Well, if I take 30 times the sine of 70 times 0, that's just going to be 0. So my work is going to be 2052 foot-pounds.